So, good morning, everyone. Let's get started. It's 9 o'clock. Some of you look like they had a very good party last night, a long one as well. But I hope you're all fresh and wide awake again for this talk on Gradle. The Android build system is a beautiful piece of software. And in this presentation, I would like to give you a bit more insight of what makes it so beautiful with respect of Gradle, or with the perspective of Gradle. Basically, the Android build system consists of the Android Studio, built on top of IntelliJ. It consists of the Android Gradle plugin, built on top of Gradle. And the focus for today is really show you the underlying power of Gradle and how you can apply it to your Android projects. Because there's a lot you can get out of knowing what are the ideas behind Gradle and how can you apply them. So I hope you can take something from that with you to your daily work with Android Studio. Before we dive into it, I'd like to just make a short poll. Who's already using the Android Studio? Okay, so that's like 85 or 90%. And who would consider himself a really solid Gradle user? There's some shy hands, but one or two really strong hands. Okay, so I would say most people are using Android Studio, but most people are not very solid or familiar with Gradle. Okay, and I hope I can change that just a little bit today. What makes it so beautiful for us at Gradleware, when we look at the Android Studio, and we want to see this with other IDs as well, is that there's a single truth of build logic. Right. Every build logic is, or all the build logic is in the build, as it should be. There is no build logic anymore in the IDE. So if you compare this to other scenarios, you have your build, which is all fine, but then when you go to the IDE, you configure your IDE again to make it match somehow how your build looks like and works like. With Android Studio, that's not the case. All the build logic is in the build, and the IDE is just a consumer of that build. Right, and it interacts with that build, but it has no logic anymore. And that's a really nice separation of concerns, and it avoids any kind of duplication as well. So all build logic is put into the build, and if you want to get information out of the build, you can ask it, and you will get the actual information that you need in terms of models. So let's take a deeper look at how is this possible, or how is this achieved to have the single truth of build logic. We can see in the center there's Gradle, that's your build system. More specifically, the Gradle daemon, that's the part that executes your build. And we'll see more about that in a second. And you can interact with this through different means. And that's exactly the point. We come from different directions, always back to the Gradle build. You can be an Android developer, you will use the Android Studio, and you will go through the tooling API and talk to Gradle. I'll say more about the tooling API in a second. You can also be on the command line, and you can still interact with Gradle. It will go through a little launcher. That's what's called when you call Gradle W, and it will still talk to the Gradle daemon. Or you can be on a continuous integration server. It will still call the launcher, which calls Gradle. So no matter where you come from, you end up with calling build logic that is in Gradle, executed by the daemon. Okay. So let's take a closer look at the Gradle daemon. So the Gradle daemon is a background process. It lives longer than your actual Gradle build execution. It's like and it's the one that does all the work. It's a bit like a dog that just waits to get a bone, and the moment you throw it a bone, it will chew that bone, and then it waits for the next one. That's like the daemon. It's just there waiting. It's all ready. It's warm. The more you call it, the warmer it gets, basically. So the JVM doesn't need to have this cold start every time. And the moment you give it a build, it will execute that build. If you want to execute another build in parallel, well, that daemon cannot do it. It will launch a second daemon. So you can have multiple daemons running in parallel, but every daemon is always ready to do work in the background. Okay. By default, the Gradle daemon is not enabled, but you can enable it through the properties file in your local Gradle user home, or through some options, or you can even specify it on the command line. Now, the thing, when you use Android Studio, you don't have to worry about enabling the daemon, because when you come through the tooling API, it's always enabled. It will always talk to the daemon. But let's say you go to the command line and you still want to benefit from the daemon running in the background, you can enable it through one of these different means that I listed here. Okay, and I can highly recommend it. So if you put it in your Gradle properties file, it's going to apply to every project that you ever do. You don't have to worry about, oh, did I forget to enable it or not? Okay. The other component I mentioned is the tooling API. So if you go back just a little bit, we see here the Android Studio developer in the top left calling the tooling API, which calls Gradle. So we see Gradle has a daemon running in the background, and we now talk to it through the tooling API. So the tooling API really acts as a proxy between an IDE or any other kind of consumer and the actual Gradle daemon. And when you talk to it, you can ask for models, but you can also invoke tasks. So as you see at the bottom, you have the client VM, that could be your IDE. You can ask for models, so you can say, what are the build types? What are all the flavors? What JDK should I use, etc. The IDE can ask all these questions through the tooling API. And you will get back that information in form of models. You can also invoke tasks. So you can say, please run that build with the task called build, or with the task called test, no matter what. This again happens through the tooling API. The tooling API is a little jar file. So you only need that little jar file. You don't need the whole Gradle install of, I don't know how many megabytes. It's just a little, I think it's a few megabytes, 1.7 megabytes or so. That is part of what you need on the client side. Now, what the Android team did is it benefits from the fact that you can extend what the models are that are returned from the tooling API. So the Android team wrote a plugin, and that plugin registers its own model. That's called the default Android project model. And that model contains all the information the IDE needs to build to set up everything properly. So everything you see in the IDE, what is configured in terms of flavors and types and what you can run, etc., that's all derived from that model that Android Studio asked over the tooling API from the Gradle daemon. Okay. The other aspect, if you call it from the command line, you call Gradle, you have the concept of a Gradle wrapper that you can use. Who's familiar with the Gradle wrapper? Okay, not many. So that is a very intriguing little piece. It's very old in terms of Gradle, but it's very powerful. What it means is you have nothing installed on your machine except Java. And let's say a Git client, and you check out a project, an Android project, and you want to build it. You don't have to install Gradle on your machine. All you can do is from the command line, you can say Gradle W build, and your build will build. And why that works is because that little Gradle W batch file or shell script will itself download Gradle if it's not already downloaded. And it will download it in the version specified. So all you need to put in your repository is that Gradle W file, and you need to put in what information do you want to use, what version do you want to use to build the actual project. And then everything will be downloaded, it will be cached, it will be reused, etc. And that's it. So think about how powerful is when you go to a continuous integration server. I mean, with any other system that I'm not aware of, build system, if you want to you want to use a newer version of the build system, you have to go to your admin and say, please install that version, and you have to make sure it's on the path, and it's first on the path, etc. This all goes away because the version of the build system that you build with is becoming part of the revision history. Right? So you can check out the state from last year, and it will use an older Gradle version. You check out the state of today, and it will use a newer version of Gradle. It's all version, and you decide when you want to upgrade. And when you upgrade, all of your team will use that version. Okay. With the Android Studio, this happens kind of behind the scenes, but I would still like you to understand the underlying concept here. Okay. What makes Gradle really powerful is that it tries to leverage the concept of DSLs. And it comes with a DSL, and you can have your own DSL. And that's basically what the Android team did. So they built their own custom domain-specific language on top of Gradle. And the benefit of that is that, as the name says, the DSL is very specific to your domain. It's specific to Android. You don't have to worry about these generic concepts of what is a task, what is whatever. You say, I want to do something with Android, and you get all the properties available in the context of Android. And it becomes really easy to configure your project, your Android project, as described here, for example, in a very, very simple way. Okay. So really what you describe is what you want to happen. You don't describe how it should happen. What should happen. It's very declarative. But what happens behind the scene can be very complex. So even though you have this very expressive, very easy to use DSL, underneath what the plugin does with whatever you configure can be very complex. And what you see here is a kind of a graph of what happens when you build an Android application. Okay, this might not even be up to date anymore. It might even be more complex today. So a lot happens behind the scenes, hidden behind that very expressive DSL. Now, we have a rich DSL, or very expressive DSL. The other key component here is that all of this very expressive information is mapped to a very rich domain object model. And that's something you should all be familiar with because you all work in object-oriented languages. We have really a very strong or rich model. And it comes with all the benefits that you have of a rich model. So you can ask very deep questions like, what is available of that type? You can traverse object graphs, etc. And that's what happens in this example. So you see, there it's called Android, is the top level. That's an extension. That's something that's registered with the Gradle build through the plugin. So when you say Android, Gradle will map that to an extension object. That's an object. There you can call, or you can say build types. Build types is a named domain object container. That's again a rich object. It's a collection object. And for each type you can define debug and new types that you want to use or flavors, etc. So all this is mapped to objects. And once you have these objects and these object graphs, you can traverse them, you can query them, you can manipulate them. Another good example here is you see this JNI debug init with. So JNI debug is a build type, and debug is also a build type. And we access the debug build type by saying build types.debug. So we just get it by name, basically. And then once we have that object, we can pass it to the initWith method. Right? So it's really, if you looked at the code, you would see that there is a method called initWith, and it takes an object of type build type. Right? So this is all modeled in terms of objects, which makes it very expressive to write and very rich to interact with. Let me give you another example from the Gradle object model. So even if you didn't use the Android plugin, Gradle itself comes with an expressive DSL and with this whole object model. On the first line we see, or on the first paragraph basically, we see all projects, repositories, JSON. I assume you know what's happening here. Right? It's going to apply the JSON repository to all your projects. Now imagine you have a project of 5,000 sub-projects, and such projects exist. You could either go and do this manually on each of these 5,000 projects, or you could do a find and replace if you wanted to add a new one or change an existing one, or you can use something like this. There's another advantage to this. Let's say tomorrow somebody adds another project. It will automatically be configured with that repository. So it's kind of even future-proof. Second example, does anybody have an idea so early in the morning what this little piece is doing with the tip tasks? Okay. It looks like some people look like they have recognized what's going on. All right. Okay. So we go over all projects, no matter how many there are and how many there will be tomorrow. We'll just go over all of them. And we fish out all tasks that are of type zip. So again, each task is an object. Task is your unit of work. It has a type. So we just fish out all these objects that are zip tasks. And then we say, well, let's take all these zip tasks, but only those that start with the name images. So every task that starts with images and is a zip task will match that filter. And now we go over all these tasks that match, and we say, add a classifier that's called images. So basically, when it creates that zip file, it will have a classifier -images. Okay. So if somebody adds a new project or adds a new zip task to one of these projects, it will automatically be configured that when it creates the zip task, it will have the classifier called images. Right? So you can have kind of rules that apply very broadly. Of course, you can make this more restrictive and say it only applies in this case. But here, for example, we want to apply it everywhere where these conditions are matched. We have a third paragraph there called task images jar, which is of type jar from images. Now, it might not be obvious, but what will happen is if you call images jar, it will also have that classifier. Okay. And there are two reasons for that. Well, the type is jar, not zip. So why do you think it still matches? Yes, inheritance. You don't know that. You don't know that jar is a subclass of zip. I know you know inheritance. You don't know that jar is a subtask of zip, but I'm telling you. Okay. So because jar is a subtask of zip, it will still match that task with type zip. Right. But the other thing that is kind of surprising is that we declare that task images jar afterwards, after that rule that we just defined above, but it still applies even though it's written later. And that's because this image zip tasks.all that you see above is a live collection, which means it not only applies at the moment it's applied, but only later on if that condition is still true. Right. So in your very first line of your Root project, you can say, this is what I want to match. Zip tasks that match and start with images. And then nothing will match because no other task is available then. But as it goes through all the sub-projects, and now these tasks are added, and they do match, they are automatically applied this classifier. Right? So it again means that you don't have to do this at the very end of your build. You can define that at the beginning, and it will still apply as the build is evaluated. Right? And the other thing I mentioned is it will apply to projects that don't even exist today as you add them tomorrow. So this makes it very robust in some sense that you don't have to, that it will kind of catch the requirements of tomorrow, I would say. Okay, why is that possible? Because it's all expressed in terms of objects. The live collection is an object, tasks are objects, everything is an object. And then you can operate on them. I talked about tasks, so just to give you a bit more of an idea, when you work with build types and flavors, which gives you a variant, one build type, one flavor, you end up with a lot of variants, potentially, and that adds a lot of tasks. I'm going to show you in a second. So because you have the Cartesian product of each build type with each flavor, right? And that kind of explodes. And if you had to express this explicitly for each combination, that would not scale at all. All right, so let's look at tasks. I'm going to go to the command line in a second, but just want to go a little bit more into the practical aspects. So just have a few hints. If you ever go to the command line, and who does go to the command line to execute Gradle? Not many. There are a few, maybe 10 people. But I mean, that's a good sign. It means that you can basically do everything you need to from the Android Studio. That's a good sign for Android Studio, that you don't have to go back to the command line. And that's exactly the goal, that you get all the information from the build into the IDE, and you can do everything from within the IDE. I mean, there would have been a lot more hands up, let's say, 3 years ago, because you didn't have this deep integration. But the deeper it is, the less need there is to go to the command line. That's excellent. That's actually a good answer. But if you ever wanted to go to the command line, a few tricks. So you can use like task name abbreviations using camel case syntax. So some of these tasks are really long. If you go to the command line, you will see there, because they're combinations of flavors and types, and you want to compile them, etc. Really long names. And instead of just typing them all the time, you can use the camel case, just like you use it in IDEA. It's the same concept. Also, if you want to have more information about the output, because Gradle doesn't spit out a lot of output by default on purpose, you can say -I or -D to get more information, debug information, or just information. You can also get more information about the task. You can say like Gradle help, --task, and then pass a task name, and you get more information about that task. That's a question I get asked a lot. What can I do with that task? And it gives you some more information. There's also the difference between a task, a project task, and a task selector. And here the idea is, if you're top level in your U project and you say Gradle build, it will call build on each project that has that task name. If you say Gradle :build, it will only call it on that project that you're in, or on the root project, I should say, on the root project. So there's a difference between these two ways of invoking a task. Just to make you aware. A few more things. You might do some fancy stuff in your build, and you want to see what the implications are, but you don't necessarily want to run it for some reason. Maybe you don't really want to connect to that device, or you just want to see, does that task even get invoked, or is it considered up to date? You can do a dry run, right? -- dry run. And you will see all the tasks that are called. You will see if they're up to date. You will see if they're skipped, but they're not actually invoked. The logic is not invoked. And you can also do a profiling. Has anybody looked at the lint reports? Okay, so from the command line you can do the lint, and it will give you this big nice report of all the things that you can improve in your build. Very Android specific. But there's also a generic profile report, and I'll show you in a second as well. And that profile report will tell you where the time is spent while the build is executed. So let's say your build takes always a minute, and you're like, well, where's that time lost? Or where is it invested? Depends on how you see it. If you say --profile, will give you a nice HTML report where you can see, okay, it's this one. And maybe it goes to one repository that is just really slow in answering. These kind of questions you can answer by just calling it whatever task you want to run with --profile. Okay, so let's briefly go to the command line, and I can show you that. So usually you use the Gradle wrapper, as I explained, because it makes sure you're using the version that is defined as part of the build and not some other version that by accident you have installed locally. But for me, Gradle W is still too much to write, so I have a shortcut just for Gradle. So I can say Gradle tasks, and it will show me all the tasks that I have available with some grouping. Okay. Now, these are not all the tasks. These are only the tasks that make the most sense to work with, defined based on some algorithm. If you really want to see all the tasks, and that brings me back to that graph you saw in the beginning of the complexity, these are all the tasks that are generated just for a super small sample project. Doesn't even have flavors. Okay, so there's a lot going on. And all that is wired properly available for you when you call with --all. I also showed the camel case, where you can say signing report, gives you that signing information if you want to have some more details, -I. But you see, by default, you don't get a lot of output, and that's really usually what you want. You don't want to have all this noise, etc. Okay, you can also do the dry run, or you can do a profile. Okay, and then you see the profile report. So that would just be profile. So if you want to see what takes a lot of time when you run signing, giving you the signing report, you can say --profile, and you will find it in your build folder. Right. So these are some of the things that you can see. And if you want to just get more help on what is it actually that you can call, you just go here. Okay, so for example, you want to run the build, but you want to use the daemon, and you, for some reason, you haven't enabled it by default. This is one way to invoke it. Right. So here you find all the options. There are not too many. It's kind of still absorbable, I would say. Okay, so this is if you ever get lost on the command line. But if you don't have a need for it, I think that's good as well. Okay. So we saw the DSL to express what your build should do. We saw that it's mapped to domain object model that is very rich, that allows you to ask very advanced questions and do advanced stuff. We then saw that there are tasks that are your unit of work. These are the ones that actually do something, and they are wired up with each other. Now there's one concept about tasks that is really powerful. And you might see this. Let me go back to I'll go back to the command in a second. If you run Gradle build twice and you didn't change anything between, it usually runs very quickly and doesn't do anything. So why doesn't it do anything? Because it knows nothing has changed or there is nothing to do. And how does it know that there is nothing to do? Well, it asks that question for each task, not for the whole build, for each task. So if you say Gradle build and it comes to the compilation phase, each task has defined a set of inputs and a set of outputs. The inputs are what it consumes to do its work. The outputs are what it creates as part of the task. And if it remembers what were the inputs and the outputs the last time. So if you run the build again and nothing has changed in terms of the inputs and the outputs, it doesn't have to do it again, right? So let's say you compile and the sources are here, and you compile, the classes are here. Now you run it again, and since it remembers what were the sources and what were the classes, and it sees, well, it's exactly still the same. Nothing has changed here, and this is still here. Well, I don't need to run it. And it does that for each task, and so if nothing has changed for each task, nothing needs to be done. That's what makes it fast. And this is not based on timestamps. This is based on hash values. So even if you changed, let's say, a source file, and you add one character to a comment, it will have to recompile because that source file has changed. But if it comes to jarring up these classes into a jar file, it will not have to do that again, because just because you changed the source code didn't actually change the class file in that case, because you just added one character, one comment. The lines don't shift, nothing changes in the bytecode. So it will not do the jarring. And because it doesn't do the jarring, maybe it doesn't recreate the var file. And because it doesn't create the var file, it might not do whatever. So there's a whole chain. And if things are up to date, the next step might not have to be done neither. So if you ever write your own task, that's something to keep in mind. Add your inputs and outputs, define them such that Gradle knows, oh, it didn't change, I don't have to do anything. Okay. Very powerful concept based on hashes. You can take that further in your DSL. How do you express dependencies? And I give you one little example here. I want to create a zip file that contains the Java doc and the Scala doc, because for some reason I use both in my project. Now I could say, well, for this zip file I need to go, please generate the Java doc from that folder and give me the Scala doc that was generated into that folder. You can do that and it works. But this is not how it's meant to be done with Gradle. You can be more abstract, more expressive. You can say, into the Java folder, I want to get whatever the Javadoc task produces. And what does it produce? It produces whatever is defined as its output. So the Javadoc task says, my output is, I put stuff in that folder, right? And now the zip task just says, well, whatever the Javadoc task produces, and wherever it produces it, take it and zip it up. Same for the Scala doc. The only difference is that I reference another project for the Java doc. So you can also see how you reference another project. Okay, and that is very expressive. So let's say that for some reason tomorrow you decide that you want to generate the Java doc to another folder. Fine, generate it to another folder. It will not screw up the zip task or your implementation of that zip task, because it will just say wherever the Java doc created the Java doc task created the Java doc, just take it from there. And if tomorrow that's another place, I'll just get it from there. It doesn't matter where it's coming from. Okay. And the other thing you get for free by doing this is it knows when you run zip docs, it has to first run the Java doc task, because it needs the output of the Java doc task. So it does an automatic wiring of your task dependencies, right? This happens without you having to think of, oh, I run zip docs, but it needs the other task, so let me add a dependency for that manually. Okay. So this happens automatically. So again, you say what you want to end up with, but you don't say how to do it. Gradle can basically take care of it because the way you expressed it is rich enough. So very powerful concept and also very easy to read. Into Scala from ScalaDoc. Yeah, that's pretty obvious. Okay, so we've looked at tasks and we saw there are inputs and outputs and we can wire them up, have task dependencies. There also, tasks are bundled in projects. And as I said, you can have thousands of sub-projects as part of one multi-project build, and each one comes with its own tasks. Then there does not necessarily have to be a one-to-one mapping between your project directory layout and how it's mapped to your Gradle hierarchy. And I just wanted to give one small example here how you can do this. So there's one file called settings.gradle, and in there you can do whatever you want to basically to map a hierarchy, a directory structure to a Gradle project structure. Okay. You can say I only want to take the lib folders, or I want to make everything uppercase, or I want to transform dashes to I want to just take away dashes and make the character uppercase. Whatever, that's up to you. So a lot of flexibility there as well. You can also have project dependencies, even though in the end they are always on the level of a task. So you can say, I have a project X that has a compile dependency on the output of project lib2. So what this means is if you compile the classes of this project X, it knows it first has to build the output of project lib2. Because it needs that as a dependency of this project X. Right? By default, it's using the default configuration, but you could have another configuration if you want to use that and explicitly define it here. The second part I only posted here because I had been asked that question before. How do you depend on a project configuration that is not the default one? Okay, but so again, to show you, you can say, in order to compile my project X, I need another project Y. You can define that like it's written here, and Gradle will take care of wiring the tasks appropriately, knowing it has to first compile the other project, generate the output, and then pass that output as a dependency to that other project. And if that other dependency changes, or the content of what project lib2 generates, it has to recompile the classes of your project as well. Okay, so the up-to-date checks come into play again here. Dependency management. Already today, Gradle has by far the most powerful dependency management. There's no question to that. You can have rules. How do you deal with conflicts? I mean, that's a typical case in a bigger organization. What do you do if you have 3 versions of Guava or whatever it is, which one should be picked? You can even say if you use library A, transform it to library B, because library A is a legacy and should not be used anymore. It can be very advanced in how you deal with these. And every big company that I know of is actually making use of that, because dependency conflicts are the daily business to deal with and to get a grip on. Variant-aware dependency management does not yet exist, but it will come soon. So let's say you have a debug variant, and you have a dependency, an external dependency, So you also want to use the debug variant of that other dependency, right? And that's one that's going to come soon. Where your dependency live is very flexible. It can be in JSON, it can be Maven Central, you can have a local Maven repository, or you can have your own Artifactory, or you can even have a flat directory structure. So where it comes from, in the end, doesn't not make a difference. The dependency rules and conflict resolution that you can apply is always the same. And you can, as I said, you can expect more to come here, especially when it comes to where-in-the-where dependency management, which in the Android world is very important. One thing about plugins. So if you look at the Gradle script file of your project, and who has done that? Who has opened the build.gradle in Android Studio? More. So it's like 50%. But it's still interesting, so you can still do your project without ever looking at the build.gradle. It's cool. So what happens, for those that have never seen it, is in the end, it applies a plugin to your project, the Android plugin, and some configuration about the dependencies that are required, plus where the sources are, etc. And you can define more build types, flavors, etc. And you can also use third-party plugins. So let's say this Manimo library, and we have also a portal from Gradle where you can find even more plugins on Gradle, on Android. The good thing about plugins is that you can have reusable build logic and bundle it up and reuse it across your projects. So let's say you're a development firm, you work on 3 different projects, but you always have the same kind of pattern of something that you do. You can bundle that logic up into a plugin, apply it to each of your projects, and you're good to go. Just like the Android plugin itself is a plugin, you can write your own plugins. And I just want to give you a very small example of that. One that you can do right away, because you don't even need to create a jar file and upload it to a repository and then include it, which is kind of a more serious effort to do. And it's definitely worth it, but maybe not to get started with. Maybe to get started with, you just want to play around. Let's try, would this work as a plugin? And then you experiment, you develop it, and some moment you say, yes, this is mature, this is good. Let's share this across different projects. So what you can do is you can create a build source directory. It has to be called exactly like that. It's also explained in the user guide. And whatever you define here is picked up when you run the build. So I went in here and I created a plugin. Basically, all I said is I have a class, I implement a plugin interface, and I apply implement that interface. And what I say is print the Gradle version. That's all that I do. And then in my build script, I say I want to apply that plugin. Sorry, that's here. And now that plugin is available. So if I go to the command line, whoops. If I go to the command line here, you can see it first compiles the build source. You can see that up here, maybe quickly. You can see it compiles build source, and then there is this task called print Gradle info, and I can now run it. Print Gradle info. I'm too lazy to type it all, and now it just prints Gradle version. Right. There's another way to get the Gradle version, but it's just to show you. That you can go further with this, and I just want to briefly show it. Here, I commented it out. You can have rules. Let's say you want to be sure that if you have a release build type, that the minify is enabled. This is how you could do it. Right. You can say, get me the extension called Android. We've seen the Android is the top level entry there. And if I find it, I find the build type called release. It's a named container that I fish out a certain build type. And I check if the minify enabled property is set to true. And if not, I throw an exception. Right. And now, if I apply that plugin here to application, and I run it. Well, it doesn't really matter what I call, because it's just going to apply it all the time. It will say build type release must use minification. Right. And you could extract that into a jar file. You can also do this through an init script, but I just want to give you a small example of what you can do through a plugin. Okay. Yes, that's what I meant by policy. Whether you put them into an init script that you bundle as part of a Gradle custom distribution, or you put it in your home folder, or you registered it through a plugin, or you use the -I option, there are many ways to do it. But just so you have this concept in mind, because oftentimes people say, well, with Gradle you can do everything. There's no restrictions, which is really bad. Let's use another system where it's more restrictive. No, you can be very restrictive if you want to, if you need to. Okay, so to close off, just a few things going forward. So Gradle 2.4 will come out soon, and that will be important for the Android Studio, or for the Android users in general that build with Gradle, because it's going to have significant performance improvements, especially during the evaluation, the configuration phase. So if you have a big project, it has to parse all your scripts, wire up all the tasks before it even does anything, and that's going to be significantly faster. And you don't need to change anything in your build. What's coming soon? As I mentioned before, this variant-aware dependency management, really important. Also being compatible with the Java plugin. Right now, if you want to use checkstyle or something, there is a checkstyle plugin, but it's specifically for Android, and it's not the normal Java one. It's because the Android plugin is not based on the Java one, but that will be changed as well. And there will be a new and really revolutionary new configuration model. It's really going to apply all this concept of inputs and outputs, not only to the execution phase, but also to the configuration phase. So if you run Gradle tasks, even if you have a huge project and you didn't change anything, it's just going to be instantly, basically. For the resources, sure, there's the Android plugin user guide. It's pretty exhaustive, very, very rich information. There's the user guide, there's a reference guide, there's also forums that you can go to. Conferences, Google I/O is coming up in May. There will be a talk by Hans Doctor, the CEO of Gradleware, and Xavier Ducourget, the lead of the build system, where they will show where Android and Gradle are. And there's also the Gradle Summit coming up. Yeah, Gradleware. So we develop Gradle. We also do some Android and Gradle training, and services and consulting. All right. So I hope I was able to give you a bit more of an idea of the power of Gradle that is underlying the Android Studio or the Android build system. And even though it's nice, you're always in the IDE and it does whatever you need it to do. If you ever have to, you can go to the command line and you have a better understanding of how to interact with Gradle, the concept of tasks, the concept of dependencies, up-to-date checks, the rich DSL, the rich domain object model, and the power that it gives you. So I wish you a nice rest of the conference.